In this example, I want to do another binary search algorithm, but I want to do it recursively. In the previous example, I did an iterative approach. I just want to show how you can do recursion and a base case to recursively compute, to recursively search for a value in an array. So we talked about sorting the array, or splitting the array in half with the middle value. We can do this recursively with a second function called recursive, and we still need the length. And this time, because we're doing it recursively, we're going to pass in the low and the high values, in low and in high. Okay, so the function is conceptually the same. We're still cutting everything in half. We're just going to do it recursively. So we want to make sure first and foremost that if low is greater than high, we didn't find anything. So return -1, not found. And I probably should put those there. Otherwise, we want to basically do exactly the same thing as here. And actually, I'm going to copy and paste that. Be a little bit lazy. I'm going to copy and paste all that. And the idea behind recursion is to have a base case. In this case, our base case is basically when we find what we're looking for. So we still compute the middle. We'll still search for 13. In the last example, I searched for 13. It doesn't really matter what you search for, as long as it's a sorted array and the value's in there. Can use the counter variable again. But instead of returning the middle, we're going to return the function. That's basically the way you do a recursive function call. You just return the function, and we turn the array again. Length hasn't changed. In this case, actually, wait, this isn't the right spot. This case, we return middle. That's correct. That's what we want to return, which is the value in this situation here, rather. This is where you want to return. Wasn't paying attention. BS recursive array length. And in this situation, we're going to bump up low. So the low value now equals middle +1. Same thing, and just return the function. And here, return BS recursive array. The low value and middle -1. And I think that's it. That was a lot easier and quicker than I thought it would be. Let me make sure we're calling it BS recursive, and I'm going to search for 13. Result equals -1. So it should set it up. Non-void function. If else, well, it always returns something. I think that's fine. 22. Did I get any errors? I do have an error. Where is that? Oh, I know it's down here. To find array. Oh, I need to pass in the find value. That's what I forgot. Find. Okay, so we'll make sure we keep finding the value. Alright, took care of that. And down here, we need to make sure the function calls right. We'll do 0 and high, which is the length, for starters. And now let's compile. Warning 22. I mean, it has if and else, so it's always going to return something. Control reaches end of non-void. I guess I can, if it gets out here, to get rid of the error. Always want to get rid of errors. Okay, now run this, and it should find 13. Found 13 at index equals 5, and only took 2 iterations. Oh, that's pretty cool. Last time I ran this with the iterative approach, it took 3 iterations. So I guess it computed it quicker, which wouldn't really make sense. Or maybe my counter variable ran 1 less time. I don't know. But yeah, that's basically the recursive binary search call. And that's basically recursion in a nutshell. And that's basically recursion in a nutshell. You just call the function, and then you need a base case. If I didn't have this base case up here, or if I didn't find the value. So basically, either I find the value and I return the middle, which is the same as the iterative, or I index out of the array. And this is eventually going to happen the way I have it set up. Eventually, low and high are just going to get too high. Low is going to go too high, or low is going to go too small, and it's going to eventually just exit out. And we can test that really quick. I'll look for 130, some 136.4, which is obviously not in the array. Run that. Was not found. It took 3 iterations. So that's basically the recursive version of binary search.